Okay, so I'm going to be talking about an introduction to artificial intelligence here. Now, these slides are part of a talk that I've given before on AI for good. So there's going to be a particular slant to them. The recording from this session will be later uploaded to YouTube, and then you'll all be emailed out a link to where to go to get that recording. And if you're inside BCU currently as a student or as a member of staff, then you can just click play on these recordings. But for everyone else, you just get the link sent through to your email, and I've got your email addresses because you signed up for the event. One thing I was asked as a late question really about the course was about the placements in particular. So how the placement program works. In essence, it works rather like an undergraduate placement. So we'll advertise to you that we've got some companies who've come to us and said we're willing to take on placement students, but also it's down to the student ultimately to go to get the interview, so apply for that placement job, and you do have to apply, and then to get the work. Some of it will be paid, some of it will be unpaid. There's about a 50-50 split, but it is just experience for you. Okay. We can talk in more detail and introduce you to the placement team in September, October time. So, AI for good. Before we talk about AI for good and particular uses, it's most important for us to define AI. And that's one thing it's a bit woolly, lots of the definitions that people use and how people think about AI. So let's talk about it formally. AI is a branch of computer science concerned with replicating human intelligence in machines so that those machines can perform tasks that typically require human intelligence. For instance, planning, learning, reasoning, problem solving, and decision making. Okay, you need some level of human intelligence to do those things. Okay, you can't get animals to plan effectively. There's an innate ability, perhaps in some animals, to prepare for hibernation for winter, to store up nuts, for instance, for squirrels. But that's a societal aspect, and it's been bred into them. We're talking about decision-making aspects in particular here. Now, there are 3 types of artificial intelligence. Artificial narrow intelligence is goal-oriented. It's designed to solve specific singular tasks, like facial recognition, for instance, so that it can unlock your phone, or so a security camera can see who's walking along the road. Speech recognition. Hey Alexa, for instance, do this. Alexa is listening for your speech so that when you say Alexa, it can hear and then it can do what you ask it to do. Driving a car, for instance. Self-driving cars are an example of narrow intelligence because you're asking it to do a specific job. And searching the internet. Then we've got artificial general intelligence. Now, this is the concept of a machine that mimics human intelligence and behaviors with the ability to learn and apply its intelligence to solve a problem. So it's like a human doing something. The human brain is the blueprint for this level of intelligence. So naturally, its creation is an unsolved challenge because we don't 100% know how the human brain and consciousness works and is affected. So we can't just replicate that inside a machine. Now, artificial general intelligence in a machine will allow for potentially infinite parallelization, allowing for unified problem solving. Okay, what I mean by this is, if you think of a football as an analogy, for instance, a football game, think of like Lionel Messi standard players. So all of them like the best in the world, but they can all read each other's minds and act together perfectly and in harmony. Or think of an online game where an entire team or guild play the same strategy perfectly in unison. You've got that level of collaboration and being the best in the world at solving that problem. Okay, that level of AI in and of itself would allow for rapid technological growth and development. There was Jarvis in the Iron Man Marvel series, in essence, of films, was touching parts of general intelligence there. It had clear deficiencies, so there were lots and lots of artificial narrow intelligence aspects stitched together, but it was touching towards general intelligence. Our final type of artificial intelligence is called artificial superintelligence, and that one's a bit less well defined, but generally we say it's the point at which AI becomes self-aware. Okay, Every now and then things hit the news saying, have we reached artificial intelligence? What they mean is super intelligence here, self-aware and conscious AI. Recently, there's been a lot of talk about Google researchers saying that their language model is that does translation or understands words, and from people's speech, from the internet, from people's typing. Some of their researchers have said they think it's self-aware. It's absolutely not. It's not super intelligent in any way. It's another narrow intelligence. So it's very difficult to imagine in reality what's expected to achieve artificial superintelligence. But if it is achieved, it's expected that will change the world, the way that we work, and will become not necessarily slaves to the machines in a like doomsday kind of a way, but our lives will be fundamentally changed by the computing and by the way it's affected and used. So most of what we focus on this course and in general has to be on artificial narrow intelligence, because we're doing goal-oriented problem solving, and that's the type that we can actually teach and do, and you'll be expected to do when you graduate and get a job. So we've got artificial intelligence. So this is what data scientists and research groups are investing trillions in worldwide now, trillions of dollars. Now let's delve deeper into what we mean by specific tasks. From a computational point of view, when anyone says they're doing AI, using AI, they actually mean they're using machine learning, or ML. Apple started advertising that there's more ML in their new iMacs. For instance, it's reaching, common parlance, this ML term, but we mean machine learning. And machine learning is a subset of AI, and there are some areas of AI that are outside the limits of normal machine learning, such as the engineering and robotics aspects. Those aren't machine learning, but they have machine learning aspects to them, perhaps. But the robotics aspects are AI, but not ML. So any AI model that can be specified as what we call a parameterized mathematical construct, i.e. you can write the maths for it, that fits into the machine learning category. So this big yellow box here. If you've heard of data mining, for instance, that field relies intensely on machine learning to infer understanding and organizational value. We'll look more into the specific tools and techniques of machine learning throughout this hackathon, but I just wanted to discuss a specific area you've probably heard of recently, and that's called deep learning, or DL. Now, deep learning is a type of machine learning where instead of having a single mathematical function designed to solve a problem well, the functions are implemented in a hierarchical way, so one on top of another that learns from another and learns from another. And that way you've got you're trying to mimic what we think happens in terms of the processing aspects of the human brain. We'll look at an example of this after some of the background of machine learning, but it's worth noting that although most of the forefront of machine learning and AI research is using deep learning is not the entirety of machine learning. Okay? And lots of the problems that we try and solve with data for most organizations actually just require simple machine learning or a data-oriented solution, and not the resources that we throw at them in deep learning models. So let's talk about some examples of AI. Here we've got an example taken from Facebook where it's looking at a picture and it's using facial recognition. So it's trying to identify which parts of this image, first of all, are faces, put a box around that face, and then match that face to the billions of Facebook profiles and see who that is in that picture, so it can auto tag. Now it's constrained slightly, so it tends to auto tag just friends or friends of friends, and that makes the job easier. But it's looking at each of these faces using AI, spotting them, and then matching them. That's an AI narrow intelligence task, facial recognition. Then we've got Siri, for instance, which has gotten better over the last few years, but still isn't brilliant in terms of understanding what people are saying and applying. Google Maps, for instance, now uses AI, and Google searches are artificially intelligent in terms of narrow intelligence. So you type in coffee and it'll find coffee, and it'll try and find coffee places near you that are rated well, and it'll try and hide the ones that aren't rated so well, for instance. Then you've got other aspects like Netflix using their recommendation system, where if you've watched this, other people might like this, for instance, or other people also looked at this or purchased this. So if you don't have a Facebook profile, for instance, Richie, then it can't auto tag you necessarily because it tags based upon profiles. But it could still find that there's a face there and then that person isn't on Facebook. And probably in the future, they'll have enough data to be able to email you and say, people are putting photos up on Facebook of you. Why don't you come and join Facebook?
So that means we are not like the database is not containing or the picture of the person, particularly person. So we are not able to find by the image recognition. So that means there is a drawback of that.
Yep. So every AI or data-oriented system has drawbacks, 100%. So they will all be, have strengths and weaknesses in areas where they work well and areas where they work less well. We'll talk about this more throughout the course, particularly in the ethics part there. One of those
Okay.
particular drawbacks I wanted to highlight is an example of how Twitter used AI to start with. So we've got two pictures that have been uploaded here. Okay, and this was someone had found this out by testing how Twitter determined what was going to be shown as a snapshot to a picture. So when you upload a picture to Twitter, if it's too big to go in this little square that shows their picture, it then shrinks out or focuses on just one part of the picture and then shows it. And it tries to show what it thinks is the most interesting part of the image. So I'm going to show you what this picture on the left looked like. When it was uploaded, it looked like this. And this is an example taken specifically from Twitter. And we're going to look at how the Twitter's facial recognition and image understanding algorithms are racist. Because the picture on the right looked like this. They'd swapped the people round. So in essence, it was looking at this picture with the black man at the top, this black square, and then this white man at the bottom, and determined that the most interesting part of this picture that needed to be shared was this white man here. So here. It then got posted this image on the right, and instead of going the most interesting bit is at the bottom, it found the picture of the white man and put him up there. So the algorithm was inherently racist, biasing towards showing the picture of the white man rather than the black person. And this isn't just limited to Twitter. We've got an example here from Zoom, which was massive at the start of the pandemic, obviously. People using it all over the place, but lots of people had technical issues with it. And we've got an issue where Zoom's automatic background is having a problem trying to see this person. And he's talking to his friend who's a tech support there, and whose Twitter account this is, that he shared this. So they suggested using a normal plain background, good lighting, all that stuff, but it just didn't work. The virtual backgrounds were constantly making Zoom hide his head. And it just so happens that the person was black. So Zoom's automatic virtual background algorithm was inherently saying that his black skin would be part of the background and therefore should be removed from the picture. Okay, they were told about this, they corrected this, and that's a good thing to see, and we need to make sure we're calling this out whenever it happens. But how on earth this went into production and wasn't tested to make sure that things like this didn't happen, and that things like this didn't happen to start with? Okay, this is part of the problem that we have with AI that I mentioned earlier, why there are too many people like me testing these algorithms on people who look like me, and then all of a sudden finding out that they are inherently discriminatory and that they need to be fixed. Okay. Now, in terms of machine learning, which is most of what we use in AI, that can either be unsupervised or supervised. If we split up those two things, unsupervised is a situation where you've just got some data and you need to find out what's going on. Okay, maybe you need to group them together and then look at what those groups are looking like, but you don't know anything about those to start with. You're just going to ask the machine learning tools to group them for you, or to look at what the probability of something happening is. That's machine learning, but you don't have a specific task for it to do. Then we've got the supervised case, like, for instance, here's a driverless car, where everything is color-coded based on the machine learning and AI algorithms and tools to say what it thinks they are, if they're of interest. So it's looked at this picture and then colored the road purple, and it's correctly worked out pretty much where the road is. Where other cars are, it's put them as orange, and it knows that orange things are different from purple things or green things. Green things are people, and you need to know what they're doing and they're not going to walk out in the road. And it's seen lampposts. and signs, for instance, it's coloured those yellow and will react to those differently. It hasn't understood zebra crossing as a differentiator from the road, and that's a problem, a big one. It thinks that there's a car over here on these steps, but it's actually just people's feet and shoes. Okay? So AI algorithms aren't perfect, and that's why we need to make sure there are safety mechanisms, things put in place before we do widespread adoption of things like driverless cars. Another supervised example might be predicting the future, and we'll talk about stocks and shares and things like that in the applied AI module in semester 2, but also in other engineering applications and in healthcare. If you want to predict what's going to happen to a person, you can use machine learning. And I'm actually working quite closely with a doctor at the moment who's trying to look at predicting demand for hospitals based upon COVID and upon other factors as well, to see when they need to have more staff and how you can react to that perhaps. So we've seen all of this data up until 1955. From then on, can we predict what the demand for air passenger flights will be? Now, deep learning, I mentioned, is what we call hierarchical, i.e. it looks at the data that you show it, and then it does lots of different decision things rather than just one thing, and then outputs information. Now, what we've done here is we've shown it some faces, in particular, and shown those to the deep learning algorithm. And the deep learning model is going to pick apart different things that it thinks are important in trying to work out whose face is whose when it's doing facial recognition. It's going to look at the eyes, it's going to look at the ears and the nose, and it's going to look at these parts independently or separately to try and make a decision about whether it's myself or whether it's Mariam, for instance. And it's going to get abstract representations of those, which is how our human brain works. We abstract away from the images or the things that our eyes are showing us, and then make decisions about who we think that person is, and then say, oh, that's Mariam. Likewise with cars, finds abstract representations and features like boots or front windows and the bonnets and things like that to try and come up with a representation of that. So, what can AI do? Or more fundamentally, and this is a big thing that we're going to focus on in the course, what can AI do well? So AI is very good at what we call subjective discrimination. So based upon a specific amount of data or information in a specific subject domain, can it discriminate or make a decision about what should be done there? So we've got self-driving cars are the standard example here, where, as I've said, we've talked about the different colouring that it gives to a picture to say, drive on the road, do not drive on the blue pavement, don't hit the green passengers, like pedestrians, sorry, who are walking here, don't hit the orange car, for instance. So by using machine learning to classify what it's looking at, it can make those decisions and then drive safely in theory. Self-driving cars have been done to death a bit as far as AI is concerned, and ethics and all that stuff. So I don't like to talk about them too much. I think it's fairly easy to understand that. But I mentioned before about predictive healthcare. So this was work that I did when I was, after I finished my PhD, I spent 2 years working with Birmingham Children's Hospital, and we were trying to predict which children and babies were getting better and which ones were getting more sick onto particular wards. The way that we did that, we had these wireless sensors around, plastered onto their chest, and the benefit of wireless sensing is massive over patients and children and babies having lots and lots of cables attached to bedside monitors and alarms. So my job was to come up with algorithms that would work with good or bad data, often quite bad data, that would then be able to predict improvements or degeneration in people's cases. So what I'm just going to do is throw up, and again, knowledge from the data visualization module will help when you come onto this. But if I just refresh what was that window and then come here. So we've got an example here of a specific patient and their data. So I've got their heart rate, so how often their heart was beating a minute, their breathing rate, their oxygen saturation, which you can get from a smartwatch, so the percentage of oxygen being perfused through their blood. And anytime you've got a black line here was when we had missing data. So their sensor just fell off or we wasn't recording information. And that happened quite a lot. Now we've got lots of patients that were quite stable like this. where they were relatively low risk. And anytime a patient crossed this black line with their risk score, we alerted the doctors instantly. So the patient, this one was particularly well for most of the time. If I just scoot along a bit, and we're recording minute by minute data, we'll go through periods of having lots and lots of data and information missing. It makes it a bit harder to try and work out what's going on there. And this is a tool that I created for the doctors to be able to look at the data and get some confidence in what we were doing. Okay, so they could look at each of the different patients and scan through time and get confidence and believability in the AI. Now, we had some interesting patients as well, interesting from a data point of view and a medical point of view, but they were quite sick. And this is an example of one here where they crossed the threshold for needing medical intervention. So their heart rate, and it was bumbling on, their heart was beating 130 times a minute, which is relatively fast for a child. All of a sudden, for a sustained period, so for about half an hour to 40 minutes, was beating at twice that. Okay, now the human body can sustain that for a relatively short period, 30 to 40 minutes, once or twice. Any more than that, and it's really, really bad outcome for them. So we managed to be able to predict that well in advance so that the doctors could react to that, medicate, look after the patient, and prevent an unnecessary admission to the intensive care. All AI driven, all rampant with ethical issues, and all sorts of different problems there that we were trying to manage. But ultimately, we managed to come up with some sort of good system that worked for that patient. And that's what we want to get to in terms of predictive healthcare, being able to work out when someone is going to need medical intervention and stop an event from happening, rather than just being able to predict it and it's still happening. Cybersecurity is rampant with AI applications at the moment, and we have a large cybersecurity department in our university. So if you're interested in that, we can look at getting you in touch with some people to find out what they're doing in terms of the research, and maybe you want to get involved in some of that. Then we've got personalized insurance. So whenever you get insurance now, you'll get quoted for it. You have to fill in lots of forms and information for that, especially in the UK and in the US. It's moving to a point where it's massively data driven and it's all going to be very personalized. So they're going to want to know right down to your DNA in some cases in America at the moment. We're currently not doing that in the UK, but in the US they are. So in the US, they're looking at genetic profiles of people and predisposition to cancer. So are you more likely to get this type of cancer or that type of cancer? Therefore, we're going to have to pay out more of your medical bills as an insurance company. Therefore, you have to pay us a lot more money in medical premiums. So all of a sudden your car insurance might jump up, your house insurance might jump up, your house insurance, all of these different factors, because they think you're more of a risk from a medical point of view, and that'll bleed into lots of other areas of your life. Okay, car insurance is massively data driven in this country, in the UK. So depending on what job you have, depending on how you work, how much you work from home, where you work, where you live, whether your car is stored on a drive, in a garage, on the roadside, all of these factors determine the price of your insurance. And they determine it by the insurance companies using data and AI to try and work out how little they will have to pay out in case your car is stolen or broken. Can AI determine an election? This is again, a bit of a contentious point for some, but ultimately AI and data has impacted elections, and it's been widely publicised and widely agreed, the fact that it has. So we've got this Guardian article, which was talking about the 50 million Facebook profiles harvested for Cambridge Analytica, which is a company based in the UK in Cambridge, which has since been closed, although the parent company is still open and believably has that data. So they harvested all these profiles so that they could then specifically target people in the right constituencies with the messages that they wanted to influence an election. And the CEO of Cambridge Analytica was recorded on camera about saying how they influenced the election in Trinidad and Tobago by encouraging half the population to just not vote in the election. Okay. We'll talk about how you can do things mathematically and with AI in terms of election rigging that's going on currently in this country and in countries across the world. And you need to be aware of these things to spot them and to be able to raise those conversations with people so that they're aware of them too. So, can AI be used for good? Yes, it can. Can it be used for bad? Yes, it can. Is AI good or bad? No. AI is a tool. It's what we're going to do with that tool that says whether or not it's good or bad. So I think that's the fundamental question that we want to sort of end this session with is, what are you going to do with AI? Okay. How important is AI going to be for your future career? What problems are you going to solve with that? And then how can we help you do that? So, do we have any questions? I can see we've got a comment from Shubham. So, as pre-processing is a critical part of preparing data for AI, will data structure for managing computer resources part of the course in efficient ways? Okay, so bit of a technical question there, but ultimately we will talk about data pre-processing, data preparation, and the types and mechanisms for preparing data in terms of standard approaches. In terms of absolute cutting edge and most efficient ways of doing things, we won't be covering that. Most of, in fact, pretty much every one of you, when you're using AI, will not be using it in a massively resource constrained way. So we don't need to worry too much about what's like the most efficient way of doing something, because that makes it far more complicated for us to teach it and for you to learn it. Okay. We'll talk about generally efficient ways and not wasting time computationally and not wasting resources or an effort. But ultimately, whether something takes a second or half a second doesn't really matter to you. We want to teach you how to save 20 minutes if something's going to take 10 hours. If we can teach you how to save 20 minutes on that, then that's quite good. But ultimately, just whether or not you're going to save half a second from using this particular type of data structure and data format compared to this one, we're not going to worry too much about that because there just isn't time in this one-year course. But we can point you towards the resources, Shubham, so that you can look into that. Great question, Alex. How are we going to be supported to get data? So every lab activity and example we use will have data provided for you, either inside a database, or you're going to be told where to web scrape it from, or it's going to be in a .csv file or like comma separated variable. So you'll get provided with those data files for the lab activities and things. For your dissertation, it's down to you to get data generally. Although if it's an industrial dissertation or industrial project, then you can do that. The person you're doing that with, naturally, you can they will be providing you with data of some form or another. Outside of that, it's down to you. But if you're doing a mini project with someone, like I'd mentioned about that image recognition where the student had managed to get a paper published, the academic provided the data for him to work on. So there will be support available. It just depends on what data you want. And we'll be talking to you about good data and bad data, all the things the traits and things you're looking for to make sure that you can use the data for the task you want. That's okay. Do we have any other questions? So if not, what I'll be doing after this is I'll be uploading the recordings for these 2 sessions, and we'll make sure that the YouTube link is shared with everyone, and then making sure that I email out the link to all of you to download the files for the labs this afternoon, for these slides and everything that's been covered today. So that'll be coming through to you in an email, so you're ready for Aisha's session. I'd like you all to, after this, try and set yourself up on that Google Colab, so follow those slides that I'm going to be sending out, and for how to sign up and make sure that you're able to do that lab activity then that Aisha's going to talk you through. And other than that, grab some lunch, Make sure you're hydrated and not too warm today. And then Aisha is going to be covering the session at 2 o'clock on data and an introduction to Python. So a gentle introduction and activities to do there. Okay. So Alex, you've asked, do you have a previous student that is construction focused? No, I don't have one that's done a construction focused project myself, but there will have been construction oriented projects before. And it just depends what type of construction you're interested in. We have this research group and project called EcroFit in our department that's looking at using AI and data analytics to do smart and green energies for smart cities. So they're looking at a whole host of different things. It's a very big project, but things like trying to automatically work out what energy rating and initiatives that a particular house should look into and use, and trying to find efficiencies for those. So we've got plenty of opportunities, even just within my own department, let alone reaching out to the engineering department. So the name of the project is EcroFit, ECROFIT, and I've just put that in the chat. Okay, Suraj, is Kaggle good for learning more about data sets, data analysis? Yes, 100%. Kaggle is a great source of data and to see other people's code, because lots of people who do some code, they upload some of the introductory notebooks and how to do pre-processing and things with the data. So if you can get into Kaggle, absolutely go for it. We'll introduce that properly for the people who are not familiar with Kaggle or have any programming background in September. So we'll talk about it then rather than here, because we're talking about the foundations of the programming and things. So we're a step or two before getting ready to do Kaggle. Okay, I'm going to stop the recording there for this session.